The aqueous water from air system design can be explained in two steps. Step 1, water absorption, and step 2, water extraction. Let's see a diagram first. Step 1. In step 1, water vapor is absorbed into a liquid desiccant. In this case we use glycerol. To do this efficiently, it is necessary to spread a thin layer of concentrated glycerol, of for example 95 weight%, on an appropriate surface. Air diffusing around this surface brings water vapor into contact with the glycerol. The water vapor is spontaneously absorbed by the glycerol until equilibrium is reached between the vapor pressures of the glycerol solution and the air. The resulting hydrated glycerol or glycerol water mixture is our water reservoir. Step 2. In step 2, we recover the water absorbed by the glycerol in step 1. In order to do that, we use solar heat and a water extraction module. In this enclosed module, the hydrated glycerol is heated by the sun, and the water absorbed by the glycerol evaporates through a water vapor permeable membrane, which only lets the water vapor pass through. This water vapor subsequently condenses to liquid water on the bottom layer of the module, which is cooled by the ambient air. The water then flows by gravity into a storage tank. This way, we have two final products: the dehydrated and concentrated glycerol, which can be reused in step 1, and our main goal, pure drinkable water. Now let's see how this works in the field. This is the water absorption module. For this trial we use an open wireframe structure holding 9 square meters of absorption surface made of cotton stripes. This structure is based on 4 segments. Each segment has a size of 110 centimeters times 100 centimeters times 11 centimeters and holds 9 bands of waffle cotton textile. Each waffle cotton textile band is 212 centimeters long and 6 centimeters wide. For the purpose of this trial, the concentrated glycerol was fed through a peristaltic pump to the upper ends of the cotton textile stripes of the water absorption module. The peristaltic pump allows us to control precisely the flow of the glycerol. Alternatively, the concentrated solution could also flow by gravity through a manually controlled valve, so no energy input would be needed for the absorption process. The glycerol flows down the cotton stripes by gravity and gradually absorbs the humidity from the air. The energy source for the absorption is the water vapor pressure gradient between ambient air and dehydrated glycerol. The water molecules move from the zone of higher vapor pressure to the zone of lower vapor pressure. The hydrated glycerol flows down the cotton stripes until it reaches a collection bag. There is one bag for all of the 4 segments, and the lower 25 centimeters of the cotton stripes are dipping into it. The hydrated glycerol is collected from the bag and is transferred to the water extraction module for the next step, the water recovery. This is the extraction unit. It is an enclosed module composed of several layers. From the bottom to the top, there are 4 different areas. The first layer is the condenser, which is cooled by the ambient air from the bottom. On top of the condenser, a thermal isolation layer is added. Then, the sandwich layer, where the hydrated glycerol flows through and is heated by the sun, is placed inside. This sandwich layer consists of a water vapor permeable membrane at the bottom, which is fixed to a black structured metal sheet. On top of the sandwich layer, a transparent isolation layer and a top cover made of polycarbonate are added that allow the solar radiation to heat and retain the heat of the sandwich layer. Each of the top layers presents two holes in the corners arranged in a diagonal way, so it allows the inlet and outlet tubing to pass through the layers. The whole module is then fixed onto the module holder frame. The whole module has a total weight of 925 grams, an active surface area of 50 centimeters times 50 centimeters, and a thickness of 35 millimeters. During operation, the water-containing glycerol solution, or hydrated glycerol, enters the multi-layer structure of the water extraction module, which is heated by solar radiation. The water molecules of the heated hydrated glycerol evaporate, and the water vapor passes through the water vapor permeable membrane. After passing the membrane, the water vapor condenses on a surface that is cooled by the ambient air. This pure water is then collected into a storage vessel. Our final product? Drinkable water. Measuring devices were connected to the system for the competition purposes. A peristaltic pump was used to control and measure the flow rate of the concentrated glycerol solution to the water absorption module, and also for pumping of the hydrated glycerol into the water extraction module. The energy source for the liquid desiccant pumping is electrical energy from the local electrical grid, or it could also be supplied from a storage battery connected to a solar photovoltaic array. The liquid water output is recorded by a tipping bucket gauge. The weather conditions were recorded by a Davis weather station with UV and solar radiation sensors. WeatherLink software was used in conjunction with a data logger mounted in the station console. Now we will show you our system working and in its most active state during the Phase 1 test period of the XPRIZE competition. This is the absorption phase. Its most productive period is during night, where the highest air humidity levels are reached. Here you can see how the glycerol, which is absorbing the water vapor from the air, is poured onto the cotton waffle fabric stripes. The glycerol flows from the top to the very end of the cotton fabric stripes, where the water-containing glycerol or hydrated glycerol is collected into a storage recipient and is then used in the second phase. Although it is not possible to appreciate the evaporation of the water and its separation from the glycerol, the condensation process is clearly visible. Here you can see how the water condensates on the bottom surface, the condenser. And then, by gravity, flows down to a tube that leads to the water collection jar.